Today we are going to start Chapter 4. 4.1 uses graphs to relate two quantities. Visually, we can represent relationships between two variable quantities as they both change. Example 1 says the graph below shows a volume of air in a balloon as you blow it up until it pops. Describe how the variables are related. In graphs such as these, the variables are the things identified on the x-axis and the y-axis. For this graph, the variables would be time and volume. Now that we've identified our variables, we want to explain the relationship that we see between them in the graph. For the first part of the graph, the line is increasing from left to right. This is where the person is blowing up the balloon. In the next part of the graph, we have a horizontal piece, which is representing the person blowing up the balloon taking a breath. Time is increasing, but the volume is not increasing for that portion of the graph. This pattern of blowing up the balloon and then taking a breath repeats 2 more times. When you get to this portion of the graph, this is representing the balloon popping because the volume suddenly decreases to 0. When you write your answer to this problem, it should look something comparable to the answer given below. This answer says that the variables are volume and time. The volume increases each time you blow, and it stays constant each time you pause to breathe. When the balloon pops in the middle of the 4th blow, the volume decreases to 0. Example 2. A band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph best represents the data shown in the table? As we look at the table, we recognize that over the 4 days, the downloads are increasing. Between the 3rd and the 4th day, we have a significant rapid increase in total downloads. So we want to make sure that our graph is showing an increase from left to right. The only graph that does not show an increase from left to right in total downloads is graph D. So we can get rid of that one to start. As we look at the remaining graphs to choose from, we see that graph B shows increasing in total downloads. However, when you get to the 3rd and the 4th day, there is a rapid increase, and so we have a slight curve in our graph. B is the best selection for this answer. Example 3. When Malcolm jogs on the treadmill, he gradually increases his speed until he reaches a certain level. Then he jogs at this level for several minutes. Then he slows to a stop and stretches. After this, he increases to a speed that is slightly lower than before and jogs at this speed for a short while before slowing to a stop again. Sketch a graph that shows Malcolm's jogging speed during his workout. Label it. For this problem, we first need to decide on the variables. The variables are going to be the labels for your x and your y axis. Since we are talking about his jogging speed for his workout, we want to have one variable that represents speed along the y-axis, and the other should be time along the x-axis. Now, when we create the first part of our graph, we are going to show Malcolm increasing his speed. Then, when he reaches that speed, he runs at a constant rate. And so we want to next draw a horizontal piece that represents that constant rate. After he jogs at that constant rate, he then decreases his speed and stops to stretch. So we would leave a little open space here. And then he picks his speed back up, but it's not quite as fast as when he was jogging before. So we're going to stop that portion of the graph there. The next horizontal piece that we draw is going to represent him jogging at that constant rate. And the last portion of the graph is going to represent him slowing and stopping again. It is important that after you draw your graph, you also label the different pieces of your graph and what they represent. For example, you would want to make sure that each different line segment has a label for what it represents in the problem. So you can see here that we should put increasing speed for the first part of the graph, constant speeds for the horizontal pieces of the graph, and decreasing speeds for the line segments that go down from left to right. We should also make sure that we've pointed out this gap in the graph along the x-axis is where Malcolm is stopping and stretching.